Long before telescopes mapped the sea of night, sailors marked a bright star low in southern light. Through early lenses, two suns came to be,
Alpha Centauri A and Alpha Centauri B. In 1838, Bessel showed the way. First published parallax, stars farther than we'd say. In 1839, Henderson made it clear Alpha Centauri's distance was measured here. From older guesses to numbers we trust, 4.37 light years away from us. In 1915, a fresh clue came in view. Robert N spotted something new, a faint red neighbor near the bright past Q. Proxima Centauri was declared true. Nearest of all, yet small to see, a quiet ember in our galaxy. Alpha Centauri A, spectral class G2V, about 1.1 solar masses, steady to see. Radius near 1.2 to our sun's size, luminosity near 1.5, warm skies. Alpha Centauri B, spectral class K1V, about 0.9 solar masses, burning quietly, about half the sun's light, orange in its glow, a cooler, tighter furnace with a slower flow. Alpha Centauri C, spectral class M5V, about 0.12 solar masses, faint to see, a red dwarf ember where magnetic storms fly. Sudden flares erupt and stain the crimson sky. A and B circle in an elongated line. About 80-year cycles mark the time. Their separation range is 11 to 36 AU, mean near 23, observationally true. One astronomical unit is Earth to sun distance in space, so those big numbers trace a sweeping pace. Proxima Centauri is bound at a distance wide, 13,000 astronomical units on its ride. Roughly 500,000 years for one full round. Distant companion, yes, system bound. To confirm world's orbit, Proxima Centauri we see 99 in Proxima Centauri B and Proxima Centauri D. The first has an orbital period of 11.2 days, 0.048 AU from the star it stays. First reported in 2016, a genuine breakthrough, mass 1.055 Earth by view. The second has an orbital period of 5.1 days, 0.028 AU from the star it stays. Reported in 22, the two confirmed in 25, mass 1.026 Earths, the data derived. A third world was proposed, Proxima Centauri C. Longer, colder, farther would be, but signals fade in the stellar noise within, needs repeat signals to make it clean. Back in 2019, a warm point showed near Mark C1 with a starlight flow. The James Webb Space Telescope steadies its eye, mid-infrared vision in the silent sky. Near Alpha Centauri A, a faint warm hue, perhaps a giant world in a temperate view. Place it between 1 and 2 AU from the star. Saturn-like size, not small by far, still candidate status while tests proceed. More seasons must check the moving lead. Stack past hints with orbits that fit. Stable paths make a stronger kid. Nearest stars give the sharpest view. Shorter distance as details come through. A is near solar models like to compare. How might a twin-shaped planets there? B runs cooler with a gentler light. How would a world keep day and night? Formation in a binary sets a test. Can rocky worlds find stable rest? Inside 2 or 3 astronomical units around A or B, the math says stable orbits can be. Proxima Centauri flares with ultraviolet and X-ray fire. Energetic bursts push escape rates higher. Stellar wind and particle scour. Upper air, unshielded extremes, growth in and there. Closing orbits may lock one face. Day on one side and the night in place. If oceans are deep and the air stays strong, winds move heat and carry it along. Magnetic fields can blunt the storm's effect. Without such shields, molecules more easily eject. We named regional Centaurus to Alpha Centauri A. We called Telemann to Alpha Centauri B, and Proxima Centauri to Alpha Centauri C. Triple star system, bound by gravity, the nearest system to you and me.